Hello, students. Today we're going to talk about DCF, discounted cash flow model. We start with what is that free cash flow? Free cash flow is the after-tax operating profit plus non-cash charges minus investment fixed asset and minus increases in working capital. The formula here, in terms if you want to see more algebra here, free cash flow to firm is EBIT, 1 minus T, EBIT earning before interest and taxes, and then plus depreciation and amortization. And then we have a CapEx, which is capital expenditure, and changes in net working capital. Well, here's an example if you like it. Suppose the company revenue is 100, operating cost is 70, depreciation and amortization 5. So the EBIT will be basically, you can see the formula here, 100 minus 70 minus 5, and that would be 25. If there is a tax rate 30% or 20%, whatever is that, then the NOPAT will be 17, which is, if you change it, like make it higher, lower, for example, 0.2, then you will have a more number here, 17.5. And then the capital expenditure 8. It assumes change in working capital is 2. Then the free cash flow is 12.5. And that's exactly the formula. We just talked about it. And here is more definition of. So what is a DCF theory? DCF, in theory, it's values for a company based on the present value of expected future cash flow. Suppose they have a free cash flow today 100, next year 120, 160. So based on this, the projection of the cash flow, how much will the company be worth? Well, this is the mathematical formula here. The white is the discount factor. FCF is this, the sum of 1 plus WACC, the power T from 1 to N, and then plus. So we assume 2 period, you're growing, and then you go terminal value. Terminal value is like after 5 years, the company will go steady state. So how much will be the worth of the company? You calculate this formula, and the equity value for the company will be EV minus the debt that they have. So why I'm doing these two terms? Because the first term, maybe the company in a high growth, 20% of free cash flow, 20%. But after 5 years, it's going to converge to a terminal value at 3%. So they are not in a steady state. This is a steady state with your terminal value, but now they're still high valuation, high growth. And the free cash flow you can see is going very steep and then become to be flatter. Growing, the free cash flow growing, but now steeper than after in the terminal when you go in a steady state. So this is the growth of free cash flow. This is with this. So how to do the model with two cases? Well, we're going to calculate this equation and then this one and then do this. So we're going to assume in the first 5 years, 20% the cash flow growth. Suppose it's 50 now. So next year will be 50 multiplied by 20%, 60 and 72 and all the way to 5 years. And then the present value is use the formula of 1, whatever is that, divided by the discount factor, which is this divided by 1 plus y to the power t. So for 1 year, it will be 1. For year number 2 will be the same WACC, 10%. T5 is year 2 and on. So so this is the first year, how much cash flow, then they're gonna grow at 20% will be 60. Gonna grow at 20% will be 72. Grow at 20% will be 86. And the final year is 103. The discounted factor is just divided by the WACC. The power T, how many years from now? The sum will be 272. So that will be the sum of this first quantity. All right, so now we're going to go to the terminal value, which is the second quantity, which is this one. Well, the same, we're going to take the fifth one. As you can see here, we take that from 103 coming from here, the last year in the terminal. We have terminal growth of 3%, and this is given to you. So multiply that by 1 plus this, and the WACC is 10%. That will give you the formula here. which is exactly the formula here. That will give you 152, 1528, and then you discount it by 5 years till you enter the terminal. That will be the discounted back of the terminal value. Then you just what you have to do, you just add them up. 272 plus 948 will be 1219 minus the debt will be the equal of the firm will be equal to 1019. That's it. In appendix, I add for you, we say we go 20 to 3% immediately, but that's not accurate. In the real world, there is a transition from high growth to decline to terminal growth. So there is sometimes a lag between high growth to a terminal growth. We're going to do that with the ChatGPT, OpenAI, when I plus OpenAI. So your homework is watch this video, record your own video, make a few changes, play with this. I want to say here that we assumed here in the formula that the free cash flow growing 20% and then in the terminal 3%, because we believe the revenue growing, earning before interest growing, and this. But sometimes the earning before for interest growing like fast, the cost CapEx growing in a different pace. So, for example, this is growing 20%, that could be growing by 5% or 6%. This is the case for ChatGPT. I will solve this case and you will have a different separate video about it. But for now, our requirement from you is to learn basics, DCF, replicate the work, and do the homework, create a video, and then post it in Canvas. Thank you so much, and I hope you enjoy this video.